So we started schedule management last week, and you know we yes, so we have talked about three processes so far. And the first one is where we create a schedule management plan schedule management, and that's the process of creating a schedule management plan. And the job of the schedule management plan is to guide us on a number of things as regarding scheduling the project. For example, the schedule management plan tells us the scheduling method, whether we're going with critical path method, which is waterfall, or whether we're going with agile, and the tools are the software we're going to use. So probably you're using Microsoft Project 2021. Your schedule management plan should have it, right? The level of accuracy, which talks about how accurate our duration estimate should be. The units of measure, which talks about how we're going to measure time, hours, days, weeks. How do you measure time in your project, right? That do we measure work per day? Do we measure work per hour? That's the units of measure. How we're going to link to the work breakdown structure, how we're going to update our schedule. Is it going to be weekly, bi-weekly, and the limits of your schedule? Um, so how long can I extend my schedule? Is it by a month, 2 months? That is your control limits. Thresholds are also known control limits. So that's where we started in schedule management. Then the second process is define activities. And define activities takes us back to the work breakdown structure. And we start breaking the work packages into activities. And that's what you see in this diagram, where we have the work package, and then we start breaking them into activities and milestones. And that is what we mean by define activities. That's what we mean by define activities. Then that's where we stopped last week, is called sequence activities. So in sequencing activities, what we want to do is the activities that have been defined, right, are now going to be arranged in the most effective order. And that's what we are talking about here. We're now going to arrange them in the most effective order. So it's one thing to define the activities in your project. It's another thing to list them in the order that they should come. That's what sequence activities is all about. And we had some exercises last week. So I'm doing this recap so that we can continue the thoughts from last week. So when it comes to sequencing activities, I'm sure you should be used to the ITTOs. It's a fundamental part of understanding project management processes. So for us to sequence activities, and what does sequencing mean? Arranging activities in the most efficient and effective order. We have some inputs. Inputs are the things you're going to consider to carry out the process. Inputs also contain artifacts or documents that we use to sequence activities. So what do you need to sequence activities? First of all, you need a list of activities to sequence. We need to understand the attributes of the activities. These are the characteristics of the activities. We also need to look at the scope baseline. Why? Because that's where the work breakdown structure is. And then the schedule management plan is also there. In sequencing activities, you can also look at the assumptions you've made. Now, last week, when we were sequencing activities, we made an assumption, and I'll just try and replicate the task we are trying to sequence. One, clean Sorry, Cynthia, please, were you around when we were trying to sequence the activities? Were you in that class?
I know you mentioned the question that time that
We
is it possible to paint and do flooring? So I don't know if it's that one.
please, can you come again, please?
I said I know there was it last week where you were asking that is it possible to paint and do flooring at the same
Okay.
time?
No,
How
no.
would you do it?
Okay, so
Okay, then no, I wasn't there.
you were in the class. Okay, let's do it in this class. So let's say that we have three activities, right? One is, so this is the project. It's a wedding project, and the uncle of the bride has given the bride, right, one of his event centers. That's the business it does. He has event centers all over the city. And what it does is that it looks at old abandoned warehouses, buys them, and then converts them to event centers. That's what it does. So the uncle in the work breakdown structure, I want to connect define activities to sequencing activities. The work breakdown structure, we have the reception. The reception is, let me call this a reception, is a work package because we need to work on it. Reception. So this is a work package. In defining activities, that venue, right, where the reception is going to hold, oh, sorry, not reception. I should put venue, not reception. So that venue hasn't been used for 6 months. It's probably dusty, dirty, dusty, more of dust, and there are no tables and chairs. So when it comes to defining activities, we're going to list the activities that we need to carry out in the venue. One activity is cleaning. The other activity is hiring tables and chairs. Tables and chairs. Another activity will be decorations. Then we will now put a milestone and call it venue ready. So do you see how I'm listing the activities? I'm defining the activities needed for the venue. Do you see what I'm doing?
Yeah.
Do you see what I'm doing?
Yes.
Okay. So that means that when you are working on a project, when you create the WBS, you are going to get to the point in the WBS where you create work packages. Define activities is now where you ask your team that what are the activities we need to carry out to make sure this work package is complete. That is what define activities. So the uncle has donated the venue, but we can't just use the venue there because there are some things, there's some work that need to be done. And we've listed the work: cleaning, hiring tables and chairs, and decorations. And then we put a milestone that once we've done these three, the venue is ready. So this is the fine activity process. Now, the reason I'm doing it is I want to show you how everything flows. Now, in sequence activities, let me list all the activities again. So we have, just a minute, we have, let me list them. Let's say hiring tables and chairs. Let me call it T and C. 2, decorations. And 3, what's the third one again? The third one is cleaning. Now, in sequence activities, right, I want to explain this process. It's one thing to define activities, is another thing to sequence them. In sequencing activities, we want to arrange the activities in the most efficient and effective order, right? In the most efficient and effective order. That is what we're doing here. So my question to you is, what do you think is the best order for the venue? Let's sequence them. Now, You don't have to tell me hiring. Don't just call the numbers. I hope you can still say the numbers. So if you think it should be 2-3-1, let's use that sequence, or 1-2-3, like that. So what do you think?
So if you want to,
You say
3-1-2.
3-1-2. Okay. So I have 3-1-2. So my question is, do you think there's a more efficient order than this? Can you think of a more efficient order than this? And the reason why I'm saying so is the more efficient your order is, the more you save time and cost. So do you think there's something more efficient than 3-1-2?
I don't think so because the place hasn't been used for 6 months, so you have to clean.
Uh-huh.
So cleaning has to come first.
Okay. Hiring tables and chairs
Then
and
yes,
decorations. Okay.
yes,
So let me propose something. What about
okay.
1-3-2? Can that work?
Based on it
It
can
can.
work, yes, but based on the fact that it has not been used,
Yes.
I'm looking at the hall. Hall has not been used for like
Mhm,
6 months.
mhm. So
That's what I'm looking at. It
do you
hasn't
know
been
what do you know
used.
why I'm proposing 1-3-2?
Okay.
Because, right, imagine that the tables and chairs come in and they're not clean. I'm talking about Nigerian settings where you've ordered tables and chairs, and by the time they're probably picking the tables and chairs from one party, and then they are dumping it in your own venue. So if the tables and chairs are not
Um,
clean, right,
mm,
if they're on ground, we can clean them up with the hall, right,
okay,
before
but is it
decorations.
possible that we do this simultaneously? Because that's what most vendors do. So as you're cleaning,
Yeah,
while the cleaning is going on, the
yeah,
hiring of tables and chairs are going on at the same time.
yes. But what if it comes after, after you finish cleaning? Do you get what I'm saying? Do you get what I'm saying? It
Mm.
might be better that the tables and chairs are there and the cleaning can be planned better, and then decorations. Do you get what I'm saying? Do you get what I'm saying?
Yes, yes.
So can you see that just with 3 tasks, we've come up with 2 sequences, right? This is what sequencing activities is all about. It's actually thinking through the arrangement to look at the best possible arrangement for your activities. That's what we call sequence activities. The best possible arrangement. Now, depending on the sequence, the more efficient, right, and effective the order is, the more we save time and cost. Let me give an example. So if we go with 3, cleaning the hall, hiring tables and chairs. So if the hall has been properly cleaned, and then we bring in tables and chairs, and we have to clean them, we're spending money on cleaning, more money on cleaning, right? Because we first clean the hall first, then we are also cleaning tables and chairs afterwards. So we're paying again, right? Now,
And but what I'm saying, sorry for
yeah,
cutting you short.
yeah,
What I'm saying is most times for wedding or whatever,
yeah,
I understand the project sequence and all of that. Right? But I'm saying that most times they are done simultaneously. So that as the cleaning is going on in whosoever has to hire the table and chair, they are bringing them. I understand what you're saying, but I'm saying in the sequence, they are done simultaneously at the same time.
yeah. But first of all, you know that when you're hiring tables and chairs, you have to be sure that the vendor as tables and chairs, they have not been overbooked. You get what I'm saying?
Yes. Yes.
If that's the case, right, then you probably want to do it ahead, right? And I also understand the fact that it can be done at the same time. But I want to assume that we can't do things sequentially. I mean, we can't do things at the same time simultaneously. We can only do it sequentially. Let's just assume that, right?
Okay.
Yes. So that means that if we do 132, hiring tables and chairs first, and cleaning, even if we're going to spend more on cleaning, it might be relatively low if we are negotiating just for cleaning tables and chairs. So 132 might just be the best option if the tables and chairs are dirty. 312 may be the best option if the tables and chairs are already clean, and then we can just go 312. So you can see that when you are working on project activities, the order is important. The sequence can determine whether you're spending more or less on your activities because we need to ensure they are done efficiently. So the reason why I brought that up, I didn't know you weren't in that class, is because you can see that when we were sequencing, I had to make some assumptions. And when you make assumptions, they are stored in a document called assumptions log. So I had to make some assumptions. Okay, what if these tables and chairs come in dirty? Maybe they are not clean. So you can also use assumptions to sequence. Assuming this takes time, let's do this task first. So assumptions are also considered when you're sequencing activities. The list of activities need to be there for you to sequence. Then the attributes of the activities also are needed in order to sequence activities. These are three of the inputs here. And of course, the schedule management plan and scope baseline are also input. Now, the question is, how do we sequence? How do we sequence? So we have what we call precedence diagramming method, PDM, precedence diagramming method, PDM, right? So when we talk about PDM, what are we talking about? So remember, we're talking about sequencing and we're looking at tools and techniques. So precedence diagram method is a technique we use to sequence activities. It's a technique we use to sequence activities whereby activities are we have activities here, right, in boxes or nodes connected by arrows. So anytime you see this drawing in precedence diagram method, we're saying that activities are connected with arrows. So when activity A finishes, C can start. So if you are arranging activities using boxes and arrows, it's called precedence diagram method. Please note that, right? So we understand that we can sequence activities using boxes and arrows, also known as nodes and arrows. Now, another way we sequence is by understanding the dependencies of our activities. We're understanding dependencies. What is dependent on what? What is dependent on what? If you look at the arrangement of the activities, we all agreed that decoration should be last. Whatever sequence, whether it was 312 or 132, 2 came last. Why? Because decoration is dependent on the hall being clean and the tables and chairs being in place. So one of the ways we arrange activities is through their dependencies. What is dependent on what, right? We also have what we call leads and lags. Leads and lags. So what do we mean by leads and lags? I'm going to show you something, and let me show you what they are. So what do we call a lead and what do we call a lag? Now, a lag is known as a delay between activities. So when you're sequencing activities, arranging them, you can point out where there will be delays. Maybe delays caused by the client inspection can cause a delay, which means you can't go to the next task until the client has inspected. That can cause a delay. Another thing that can cause a delay could be resources, materials you need for the task, for the next task is not yet available. So anytime we experience delays in our projects, when you're sequencing them, you can put a lag between those tasks. And a lag is simply a waiting time. And this waiting time can be caused by anything, really. So there's nothing that really determines lag, right? Anything can cause a delay, but we can represent it by extending the, the link between tasks. So what this means is that, for example, if there's a 2-day, so if task A takes 2 days, task B takes 2 days, and there's a 2-day lag between both of them, it means it's going to take 6 days, 6 days to complete the two tasks. It's going to take 6 days to complete the two tasks, okay? It's going to take 6 days to complete the two tasks. Now, yeah. Do you want to say something?
No, no.
Okay. So let's look at lead. Now, the opposite of lag is lead. A lead is an accelerant. A lead is an accelerant, which means if lag causes delay, lead helps you to speed up whatever you're doing. Now, how does lead work? So you can see on the side what happens when we have a 1-day lead. Now, a 1-day lead simply means that task B is going to start 1 day before A finishes. That's a lead. Task B will start 1 day before A finishes. That's why it seems as if it's going into A halfway, right? That means task B is going to start on the second day, right? And A is going to finish at the end of the second day. Now, when you arrange these two tasks together like this, what it simply means is that instead of the two tasks finishing in 4 days, because they are overlapped by 1 day, the two tasks are going to finish in 3 days. That's what it means. It means that the two tasks will finish in 3 days. I have a question for you. If task B has a 2-day lead, when will task B finish? If task B has a 2-day lead, when will task B finish? Not a 1-day lead, 2-day lead now.
Is it 4 days?
No. A 2-day lead will mean what?
The 2-day lead will mean a dinner.
No,
We finish in 2 days.
no.
The 2-day lead will mean
Means that task B starts when?
task B will start when task A will
When?
start at the same time with task A.
Will
Since something
start
doesn't
when?
have
I didn't get that. When
will
will
start
task?
when task A is done.
When A is done. Is that what you're saying?
Yes.
Uh, Now look at it again. If we say 1-day lead means task B will start 1 day before A finishes, what will a 2-day lead mean?
Then the 2-day lead will then be that it would start, is it 2 days before task
Yes,
is finished?
A finishes. And when is that? When is that?
When is that? I was in time.
That means that task B will start with task A,
Okay.
because 2 days before A finishes means that task B will start with task A, which means task B will also finish with task A. That's another way of looking at it. Do you get? If 1 day lead means task B starts 1 day before A finishes, a 2 day lead will mean that task B will start when task A is finishing, because that's 2 days before it finishes, and so on. So there's a way you can look at lead that it can even be quite complicated. The reason I'm talking about this is that as a project manager, you're going to be scheduling, and this is one of the things you use to schedule your project. This lag and lead, very important when it comes to project scheduling. So that's why I'm stressing on it. So that's lag and lead. Let's go back to the ITTOs. Now, I'm sure we've talked about precedence diagram method, using boxes and arrows to arrange activities. We've talked about dependency determination and integration, understanding the dependencies, right? Understanding the dependencies to arrange your activities. That's what it means. Leads and lags, we've just talked about this, putting lags, delays where they are, and leads where you have opportunity to do so. Lastly is project management information system. Anytime you see project management information system, you can convert it in your mind to software, because largely that's what it talks about. But what are we talking about? Software that you can use uh, to sequence, like a scheduling software, like Microsoft Project, MS Project is an example. Any software you can use to sequence activities is what PMIS is talking about here. Okay, right. Uh, and of course, MS Project is not the only one. There's Smartsheet, there's Primavera, there's so many tools you can use. So at the end of the day, what do we have? The project schedule network diagram. The project schedule network diagram, right? That's what we have. Project schedule network diagram. That means that when you've arranged all the activities in your project, right? When you've arranged all the activities in your project, we should get this diagram. This is what we call project schedule network diagram. This is what you should get. Now, a network diagram is a series of activities in your project from the start of the project to the end of the project. Obviously, this network diagram has been created using precedence diagram method, because we see boxes and arrows. So that is the output. It means that when you have finished this process of sequence activities, you've arranged all the activities in your project from the start to the finish. Normally, how you do this is using a scheduling software like Microsoft Project, which is what is done most times, right? And you might also decide to do it on paper, but that's a lot of work, and it's just better to do it on software. Now, so we know what a network diagram is the complete series of tasks from the start to the finish of your project. Now, another thing I'm going to talk about is we're going to talk about dependency determination and integration in detail, because there are different types of dependencies we need to know. So let's talk about the different types of dependencies on a project. So first dependency we want to talk about is mandatory dependency. What's a mandatory dependency? Is a constraint that must be completed before the subsequent items can start. a constraint that must be completed before the subsequent items can start. That is what we call mandatory dependency. Now, the key word for mandatory dependency is must. You know, when you say something must happen, you're saying it is mandatory. Now, let me give you an example so that you can paint the perfect picture in your mind. You can paint the perfect picture in your mind. Look at this. You must have the roof on before you can begin to apply shingles to it. Let me give you another example. The ceiling must be in place before you install the ceiling fan. How do you want to install ceiling fan without ceiling? So that's a mandatory dependency. The fact that we're using the word must, or let me give you another example. The foundation must be in place before you start laying blocks. The foundation must be in place before you start laying blocks. The foundation must be in place before you start laying blocks, right? Right? Cynthia, are you with me? Are you with me, Cynthia? Yep. So the foundation must be in place before you start laying blocks, or the ceiling must be in place before you install the ceiling fan. That is what we call a mandatory. It is must. It must happen. Is mandatory. Now, mandatory dependencies are also known as hard logic. That's what they're also called. So you either call it mandatory dependency or hard logic. Now, we have another type of dependency called discretionary. Discretionary dependency goes with soft logic. But let me explain what it is. It's a constraint that should be completed, but is not absolutely required to be completed before the subsequent items can start. So what's the key word in discretionary dependency? In discretionary dependency, the key word is should be. A constraint that should. Now, in other words, it's not a must. We should, but it's not a must. If we use the word, it means that ideally it should, but it's not a must. Now, please, I'm going to ask you a few questions, right? Now, let's look at this situation. So let's assume that you have a particular study in your house where you take this course, right? And in that study, you want to paint or repaint the walls, and then you want to lay carpet. Now, don't forget, we just talked about sequencing. Which one would you do first? Laying carpet or painting? Yes, Cynthia, can you respond if you don't mind? Laying carpet or painting? Which one will you do?
Want to
Pardon?
paint the lay carpets. I will paint first.
Okay, thank you. And that's the best order, really. Because if you lay carpet first, you're going to spend more money. Not that you can't do it, but you spend more money preventing paint getting on the carpet. So that's the most efficient way. So let's say that we get a contract from a 5-star hotel, and that 5-star hotel, let's say it has 5 floors, let's say. So this is the first floor, second floor, third floor. Wow. Hope I won't run out of floors. So yes, it's not perfect, but just assume. Now, this hotel, they want us to do exactly the same thing. paint their inner walls, not outside the building. They want us to paint each floor and lay carpet, wall-to-wall carpeting, including the corridors and everywhere. They want us to paint and lay carpet. Now, listen to my question. Is it a must to finish painting? Is it a must to finish painting before we lay carpet? Is it a must? Is it? Yeah.
No.
Okay, how will you do it? If it's not a must, how will you do it?
While painting, you can let some parts, as in you can paint in sequence, since you're
Okay,
doing it for all the.
yeah.
So you can paint a particular part. Once
Uh-huh.
it gets right, you lay the carpets, go to another, just in sequence, but you don't have to
Yeah.
finish painting the whole building.
Thank you.
Ah,
You've
that will
got
take
it.
more time, more cost,
Yes, it will
and it
take
will
more
even
time.
delay your work.
Yes. So if we're pressed for time, just as you said, but let me just suggest something, right? Just as you said, we can decide to paint, and let's say it takes a week to paint, right? And when the painting team moves to another floor, we will ask so that they don't get in their way. We're going to ask the people laying carpet to start laying carpet. So we're taking a top-down approach. So starting with the topmost floor, right? And top-down approach may be better because um, you can just section off the entire floor, right? And which might mean that the hotel may still be able to run for business if the guys walking up do not make noise. So, so when the guys painting move to another floor, the guys laying carpet will start laying carpet on this floor. Now, I'm sure that's exactly the same thing you are saying. Now, let's try and draw the timeline so that we see what it looks like. Let's look at the timeline. So let's say it's going to take 5 weeks to paint. And let's say this is a timeline for 5 weeks, right? The people laying carpet will start a week. So this will be their own timeline, right? Their timeline will be like this, which means they start a week after painting, after the people start painting, and they're going to finish a week. If you look at this timeline, if they're both 5 weeks, it means that doing it this way is going to complete the project in 6 weeks, right? So let me go back to discretionary dependency, right? Let me go back to discretionary dependency. Yes, we should finish painting, but it's not a must. Look at the way I'm playing around with the words. We should, ideally, if we have time, we should finish painting before we start laying carpet, but it's not a must. And because it's not a must, guess what? We can overlap the task. Because it's not a must, we can apply lead. You know, we just talked about lead now. And what this means is that there's a 4-week lead. That means laying carpet can start 4 weeks um, before painting ends. There's a 4-week lead because we don't have to finish painting before we lay carpet. Alternatively, if let's say we wanted to finish painting and lay carpet, let's look at the timeline. So let's say this is 5 weeks. If we decided to do one after the other, this is 5 weeks, right? Then let's look at another 5 weeks. So like this. Now, the beautiful thing about discretionary dependency is that we can decide whether we want them to follow each other or whether we want to overlap them because it should be. It's not a must. It should be. So because of this characteristic, discretionary dependency are called flexible dependency because we can decide to do one task over the other, or we can apply a lead and say, let's try and overlap them since it's not a must that one should finish before the other one starts. So because of that property, discretionary dependencies are also known as flexible dependencies, while mandatory dependencies are known as what? Inflexible dependency. Why? Because there's no way you can overlap mandatory dependency. Because in mandatory dependency, the constraint, the task, you have to finish one, right? The constraint must be completed. If you look at what we're seeing here, a mandatory dependency, a constraint that must be completed before the subsequent item. So mandatory dependencies will always have this kind of sequence where one must be done before the other one. But discretionary dependency, you can choose to do one after the other or overlap them to save time. So that's where it becomes flexible and mandatory dependency becomes inflexible. So we also have what we call external dependency. What is external dependency? This is a constraint outside your project team or organization. And that means the constraint or the delay is caused by something outside your team. Look at the example here. The city inspector must approve any construction before issuing a certification of occupancy so that the tenant can move in. So that means that even though you finish your work, tenants cannot move in until an external constraint, which is the city inspector, must do their work before tenants can move in. So that's an external dependency. It's outside your project team or organization. Now, internal dependency are dependencies caused by your project team or organization. And a good example of internal dependency is when you have assigned one team member. Let's say you have an engineer. You've assigned one engineer to 5 projects working at the same time. One engineer assigned to 5 projects at the same time. What's going to happen? So the engineer cannot divide himself or herself. They're only one person. So that means some of your projects may be delayed because you only have one resource. That is what we call internal dependency. Internal dependency. So let me ask you this question before we move on. So you finished a task in your project, but you need to get a government agency to inspect the task and before you can now move on to the next task. What kind of dependency is that? You've completed a task. You need a government agency to external. External. But look at it. Is it only external? A government agency has to come and inspect. Is it only external? We're talking about government agency. Is it only, I agree it's external, but is it only external?
Mandatory.
Thank you. So sometimes when you look at your options, sometimes they may not just give you external. Sometimes they may give you external and mandatory. Now, if you don't see external alone, just know that there's something to the question, which means they can pair it up. So it could be external and mandatory, right? So sometimes it could just be external, but if you find out you don't find external alone, then you just need to check that question. You just need to check that question. So now let's talk about arrow diagram method. And I'm just going to mention it to you. I think, I don't think you'll have questions from this area, right? So I'm not really going to mention it. But if I see a need to take you through it fully, I will. But it's something that I'm trying to phase out of my training material because I don't think they ask questions on this anymore. But let me just explain it so that you have an idea of what we're saying. Now, remember, we talked about precedence diagram method, PDM. And precedence diagram method is where activities are in boxes, nodes, and connected by arrows. That's how you recognize PDM. But before PDM, precedence diagram method, there was something that people used to use, project teams used to use, and that was called arrow diagram method. So PDM is an improvement on arrow diagram method. And let me just explain what arrow diagram method is. Now, in precedence diagram method, activities are in boxes connected by arrows. In arrow diagram method, the activity itself is on an arrow, and then you connect them by node. In other words, if I wanted to convert this to PDM, all I had to do was make this a box, which is a node, right? And then make this an arrow. And if you pretty much do everything, so this will be an arrow, this node, then I'll convert this into a box. So activities were on arrows. So if I wanted to call, do you get what I'm saying? Right? There's a way to convert arrow diagram method back to PDM, right? And PDM back to ADM. So they're more or less the same thing, but the way they're represented is different, right? Now, the major difference is that in arrow diagram method, we use dummies. And what is a dummy? Activity H is a dummy. How do I know it's a dummy? It's a dotted line. If you zoom very close to it, you'll find out that it's not really a solid line. If you look very close, it's actually a broken line. So what that means is that activity H, right, is not really an activity. It's a dummy task. We call them dummy tasks. And you probably see it in the write-up here. You see it in the write-up here. If you can see my write-up, you see that there's something called dummy task. Right, that's it. Now, what are dummy tasks? Right, dummy tasks show the dependence of one task on the other. And what this diagram is really showing is that activity C is dependent on B. That's what H is showing. So activity H is not really a task. It's just showing that activity C is also dependent on B through dummy H. Now, because activity H is not really an activity, it has zero duration. So dummy tasks do not have any duration because they're not really tasking in the first place. So why do we have dummy tasks? Now, this diagram that you see here, this entire diagram is actually the same thing as this diagram here. They are exactly the same thing. Now, this diagram is easier to follow because activities are separated from the arrows. So activities, you can show the direction of activities through the arrows. Now, let's study this one. So if you look at this, you can see that activity A and B must finish before C can start. Very easy to see here. But when you go to arrow diagram method, you realize that saying that A and B must finish is not very simple. And let me go back. This is why we have the dummy task. So you can see, because the activities are on the arrow, if you wanted to say A and B must finish before C can start, you might have had to construct the arrow in this direction. But the challenge with constructing A and B to C, right, is that D is also dependent on B. And there's no way we can do it such that, you know, because if you say, okay, let D come out of here, since B is dependent on D, but you see, if you extend D out of this circle, then what you're saying is that A and B, D is also dependent on A and B, but D is not dependent on A and B. So there'll be a problem if we do not draw it the way it's drawn, because C is dependent on A, but now we have to use a dummy to show that A and B through dummy H are both dependent on, C is dependent on A and B through dummy H. You can see it. And D is also, so it became complicated. Something that we have just seen in one diagram, we're explaining it away in this diagram. That is why we no longer use ADM, right? And I think I'm going to phase it out of my training. Probably you'll be the last person who knows to hear about ADM from me, but that was what we used to use earlier. So it's time for our 10-minute break. Please confirm you can hear me.
Yes, I can.
All right, so it's time for our 10-minute break. We'll take our 10-minute break and come back and yes, continue from where we stopped. We'll talk about the difference between PDM and ADM and talk about predecessor types shortly afterwards. All right, so enjoy your 10-minute break. Thank you. So when we look at comparing precedence diagram method and arrow diagram method, right? Precedence diagram method is known as PDM, right? Therefore abbreviated PDM. Arrow diagram method, precedence diagram method is also known as activity on node, therefore abbreviated AON. Arrow diagram method is also known as ADM, right? Activity on arrow, therefore AOA. Activity on line, therefore AOL. Please don't forget the names, right? The full names and the abbreviated names of both, right? That's if they ask you questions on arrow diagram method. Now, if you look at the major difference between precedence diagram method and arrow diagram method is what? The predecessor types. For precedence diagram method, it's just finish to start, right? For arrow diagram method, we only have one predecessor type, which is called finish to start. For precedence diagram method, we have 4 predecessor types, which is finish to start, start to start, finish to finish, start to finish, okay? We'll talk about these predecessor types in a minute. And so the maximum number of predecessor types for PDM is 4, for ADM is 1. Precedence diagram method, PDM, does not make room for dummies. Dummies are not allowed, right? No dummies. And this is where I usually crack a joke that precedence diagram method is smarter because it does not accommodate dummies. Of course, just a joke. Now, in arrow diagram method, we need dummies at times to show the relationship between activities, to show dependencies, right? Precedence diagram method is used by most modern project scheduling software. Arrow diagram method is outdated and manually drawn mostly. We have the precedence diagram method sample, and we also have the arrow diagram method sample. So this is the difference between PDM and ADM, right? Now, the major difference is the predecessor types. If you look at the two tables and you're comparing them, you find out that the major difference is the predecessor types. Precedence diagram method has 4, our diagram method has 1. So for us to understand the difference between PDM and ADM, we need to understand what predecessor types are, because PDM has 4, ADM only has 1. So what do these things mean is the question. So let's move on and talk about predecessor types. So we have finish to start, finish to finish, start to start, start to finish. This is what we call predecessor types. Now let's look at the finish to start. So what does the finish to start mean? It means that activity A must be completed before B begins. In fact, you can still use the word finish and start by saying activity A must start before B begins. So A must start before B begins. This is what we call finish to start. When one activity has to finish before the other one starts. We must finish the foundation before we start laying blocks. Finish to start. Finish to start. Right? So when we talk about finish to finish, what are we saying? When we talk about finish to finish, what are we saying? We're saying that 2 or more activities can finish at the same time. Now, when you're focusing on finish to finish, it doesn't matter where you start from. When you focus on finish to finish, it doesn't matter where we start from, right? So when we talk about A and B finishing together, you want to time the activities so that they finish at the same time. Now, let me give a very nice example for finish to finish. And let me show you an example by cooking, right? And let's say you want to enjoy a lovely meal of rice and beans. That's if you like rice and beans. Which one do we start first? We start cooking the beans first. That means you time it, the beans is going to be cooking longer. Then midway, you start cooking your rice. If you time it well, they'll finish at the same time. So finish to finish can be used when you need to finish 2 activities before another one can start. So if you want to have a meal and you must eat rice and beans, then you're going to use finish to finish to ensure that both food items are ready before you can move on to the next thing, which might be to eat them. Okay, so that is finish to finish, when 2 or more activities need to finish at the same time. Then we also have start to start. Now, start to start means that 2 or more activities can start at the same time. They are not dependent on each other. 2 or more activities can start at the same time. Let's look at start to start. So using start to start, we can say that activity A, let's look at it. The start to start, we can say activities A and B can start together. Now, it simply means A is not dependent on B and B is not dependent on A, so they can start at the same time. So for example, if you are building a house and you have enough resources, you can start painting the house and at the same time paint the fence at the same time. They're not dependent on each other. So that is start to start. The last one, and the last one is the most complicated out of all the predecessor types. And the reason why I'm saying it's complicated is because you really need to understand what start to finish is. Okay? Yes. Does anybody have a question at this point? Does anybody have a question at this point? Are we getting it? Okay, I'll just continue. So we're talking about start to finish. And let me show you let's go back and see finish to start. Because we have start to finish. Now we're talking about, we have finish to start. Now we're talking about start to finish. What's the difference? Okay. So let me draw finish to start on top of start to finish. So finish to start, you have two boxes, right? And one is A and one is B. So this is A and this is B. In finish to start, we said activity A must finish before B can start. Activity A. Okay. Just a minute. So we're talking about finish to start, right? And we want to compare finish to start to finish. So let's look at, here we have finish to start. Here we have start to finish. Now, finish to start says when activity A is done, B can start. That's what it's saying. When A is done, B can start. Now, when you look at finish to start, we see alphabet A and B. Logically, A always comes before B. That's why you don't have an issue with this diagram, because A always comes before B. But let's name it better and name A as the predecessor, right? Name A as the predecessor and name B as the successor, right? We name A as the predecessor and we name B as the successor. So when the predecessor finishes, the successor starts. That's what finish to start means. When the predecessor finishes, successor starts. The question that we have now is that, what does start to finish really mean? In the description, it says activity B would start before A finishes. And that's what we see here. But if you really want to understand it in context, let's use the same rules, which means let's call this the successor and let's call this the predecessor. So what we're saying is that, right? This is what we're saying. This is what we're saying. That the successor will start before the predecessor finishes. That's what start to finish is. Now, the reason I've taken time to explain the difference between finish to start and start to finish is to also understand the relationship between them. Finish to start is done when something must finish and then another one starts afterwards. Here, we're saying that we want the successor to take over from the predecessor, so we start the successor first so that I can take over the predecessor. And the example I gave last week is currency swap. In Nigeria, currency swap has happened a number of times over some decades. And this is where probably the central bank has designed new notes and they want people to, bring in their old notes. That's this currency swap. Now, what you notice in a currency swap is that anytime there's a currency swap, they will start printing out the new money first. The new money will be in circulation. People will be spending new money and old money. and then they'll give a deadline where all old money must be put in the bank. That is the predecessor end, right? So they start circulating new money, right? And after some time, they stop the use of old money. So at some time, new money and old money will be spent together, right? I hope you understand what I mean by start to finish. Now, start to finish, another example of start to finish is if you're doing a shift job, right? So let's say you're taking over someone's shift. Start to finish is where you come in early, maybe 30 minutes early, so that when the person that finishes their shift is done, you can seamlessly take over. There'll be seamless continuation to the next. The successor is already on ground and will take over from the predecessor. So where do we start to finish? When you want one system to take over from another system so that there's a seamless transition. Okay. Do we have any questions? Do we have any questions? Or do we have any examples? Yes. Cynthia, Rhoda, do you guys have any questions, examples of start to finish? Yes, Cynthia.
I don't have any question. Your example is
Okay. Do you have
explanatory enough.
is explanatory enough? Okay, that's fine.
Yeah.
Okay, thank you. Rhoda?
No, I don't have any.
Okay, that's fine. That's fine. That's fine. Okay, so let's continue. So let's continue. So let's look at the standard path, lag or lead. Standard path, lag or lead. So when we talk about standard path, what are we talking about? Right? When we talk about standard path, we are talking about a series of activities with no lag or lead. That's the standard path. No lag, no lead. Then we have a path that has a 5-day lag, and we have a path that has a 2-day lead. Now, we're going to use this legend to understand all the numbers on top of the activities. So the number on the top left is early start, number in the middle is duration, and the number on the top left is early finish. So let's look at how activities flow in the standard path. The standard path is a path where there's no lag, no lead. That's simply what we're saying. A path where there's no lag, no lead. Okay. So let's look at activity A. Activity A will start on the first day, has a 4-day duration, and will end on the 4th day. Activity A starts on the first day, has a 4-day duration. Remember, duration is the number in the middle, and is going to end the 4th day. Now, this is a finish to start. So when A finishes, B can start. Activity A is finishing in the evening, not morning. Is finishing in the evening of the 4th day. Evening, not morning of the 4th day. So activity A will finish in the evening. B will start in the morning of the 5th. Now, don't make the mistake of saying 5 plus 3. If you say 5 plus 3, you're going to get the wrong duration, right? Because 5 plus 3 is 8. So if you say an activity is starting on the 5th, and you say 5 plus 3, if you count with your fingers, you find out that on the 8th, if the task finishes in the evening of the 8th, that's 4 days, not 3 days. So if you use your finger and say the 5th, it's done in the morning of the 5th, so the 5th is a whole day. 6th is another day. 7th is another day. That's 3 days. If you now make it 8th, you've actually added one more day to your task. The duration is no longer 3 days. Hope you understand what I'm saying. So activity B is starting on the 5th. It is going to take 3 days, 5, 6, 7, finishing in the evening of the 7th. C is going to start in the morning of the 8th. It's going to take 5 days. So you count 8th, 9, 10, 11, 12. It's going to finish in the evening of the 12th day. So that's how we count it, right? So don't just say 8 plus 5. You get it wrong, right? So there's a 5-day lag between A and B. Activity A will finish on the 4th day. So you start counting your lag. Activity B will start on the lag will start, the lag itself, what we call the lag, is going to start in the morning of the 5th day. That's day 1 of the lag. 6th day, day 2 of the lag. 7th day, that's day 3 of the lag. 8th day, that's day 4 of the lag. 9th day. That means the 5-day lag will end in the evening of the 9th day. You can count 5 days. It will end in the evening of the 5th day. So the next activity will start in the morning of the 10th. It's going to take 3 days duration, 10, 11, ending in the evening of the 12th. And activity C starting in the morning of the 13th, 5-day duration, ending in the evening of the 17th. So this is how we count. So the last path is a path where there's a 2-day lead between A and B. There's a 2-day lead, which means activity B is starting 2 days before A finishes. And what is that? On the 3rd. It's going to take a 3-day duration. So we have 3rd, 4th, 5th, and then finishing in the evening of the 5th. Activity C starts in the morning of the 6th. It takes 5 days and ends in the evening of the 10th. So that's what we are saying. 6 to 10. Now, this is how you should count activities on the activities on your task. That is what we are saying. This is how you count activities on the task. Now, let's talk about estimating methods. Let's talk about estimating methods. Now, when we talk about analogous estimating, now the reason we're talking about estimating methods is because the next process we want to look at is the process of estimating duration. So are there methods, are there techniques for estimation? Yes, there is. Let's look at the first one, which is called analogous estimating. Analogous estimating. So what is analogous estimating? It is estimates you create by comparing to something you've done before or to a previous project. Estimates you create because you've done something before is called analogous estimate, right? So let me give you an example. So an example of an analogous estimate is let's say you traveled, or let's say that you built a house and it took you 2 weeks to paint the whole house, right? It took you 2 weeks to paint the house. If you are building a similar house somewhere else and someone asks you, how long will it take to paint a house? Because you've done it before, you can use that as an analogous estimate. You can say that it's going to take 2 weeks. Now, let's look at the word analogous. You know, analogous also comes, analog comes from the word analogy. Analogy. And when you're saying analogy, you're saying that analogy means like something. So when you say, let me give you an analogy, I want to give you an example, something close to what I'm talking about. So analogous, dictionary meaning of analogous means to compare. So estimates that you create by comparing to something you've done before is called analogous estimates. It's called analogous estimate. So for this example, I'm going to use my own analogous estimate of a trip between Lagos to Ibadan. Last time I went from Lagos to Ibadan, it took me 1.5 hours, right? So if you ask me today, how long will it take you to travel to Ibadan? I'm going to tell you 1.5 hours because I've done it before from previous experience. That estimate that I've just created is called analogous because I'm comparing it to what I've done before. Sorry, just taking a drink of water. So that's what we call analogous estimate. That's what we call analogous estimate. Now, we have another estimating method called bottom-up. Unlike analogous estimate, bottom-up is quite different. In bottom-up, you have to, individual items are estimated, then summed up for the total cost. Individual items are estimated, then summed up for the total cost. So what does that mean? So when we talk about bottom-up, we have to list what we want to estimate, break it down into smaller pieces and estimate. So let me give you this example. So I'm still going to use Lagos Ibadan, but I'm not using analogous anymore. I'm not using my past experience. I want to use bottom-up. So for bottom-up, I have to break what I want to estimate into smaller pieces, estimate the individual items and sum them up. So using bottom-up estimate for Lagos Ibadan, what do I have to do? I have to break down the journey into smaller parts. So I have from Lagos toll gate to Mowe, that might take like 15 minutes, right? Then Mowe to Redemption Camp, this might take like 20 minutes. Redemption Camp to Shagamu interchange, this might take another 20 minutes, right? Shagamu interchange to Sadhguru Maharaji, this might take another 10 minutes. No, Shagamu interchange to Ogere, this might take like 5 minutes. Let's say 5 minutes. Then Ogere to Sadhguru Maharaji. That's it. I hope if you are a bit familiar with the route, I'm just showing milestones around Sadhguru Maharaji. This takes about 30 minutes. Then Sadhguru to Ibadan takes like roughly 5 minutes. So what have I done? So now that I've broken the trip into different parts, I'm going to now, right, sum it up. So this is 1 hour, 15 minutes, 20, 25, 1 hour, 1 hour, 30 minutes, 1 hour, 35 minutes. So I have actually derived the estimate, but this time around, I used a bottom-up estimate. Now, compared to analogous, you saw that analogous, I just looked at the last time I traveled from Lagos to Ibadan, how did it take? How long did it take? And I'm using that as my estimate. But in bottom-up, you have to divide what you want to estimate into smaller components, estimate those smaller components and add them up. And that's bottom-up estimating. Then we have parametric estimating. Now, let me also use parametric for the trip Lagos-Ibadan Expressway. Let's say that my car is traveling with an average speed of 100 kilometers per hour. And the distance is 150 kilometers. Now, because I have parameters, I can calculate the time. So time is going to be distance over speed, and that will be 1.5 hours. I hope you're following, please. I hope you're following. Please, if anybody asks any questions, let me know. Cynthia, are you fine? Rhoda?
Yes.
Okay, you're fine. Okay. So parametric estimating. Then we have Monte Carlo. And Monte Carlo is where you use a software to generate estimates based on probability, likelihood. So it's a software and you just put in the parameters and it gives you the estimate that you want. Okay. Now, so I hope I've clearly explained every estimating method. The last one is software, and software does it for you. Now, because we have many estimating methods, it's also good to understand their advantages and disadvantages. And when you are estimating a project, is best practice to look at different estimating methods so that you can decide on which ones you're going to use to determine your estimate. For example, we've used analogous bottom-up parametric for the same task, traveling from Lagos to Ibadan. Right. So when we understand the advantages and disadvantages, it can help us to determine which ones we'll consider on a particular task. And that's what I want us to look at now. How to do that. Let's look at the advantages and disadvantages. Now, for analogous, one of the things you'll agree about analogous is this. Analogous is fast, can be created quickly. It is fast. Disadvantage of analogous, it's not detailed. It doesn't have individual piece estimate. It's an holistic estimate. So it just tells me that Lagos Ibadan is 1.5 hours, right? That's what do you call it? That's a disadvantage. It's not a detailed estimate. It just gives me the overall estimate. Now, but before we talk about bottom up, I want you to notice something. Top is the opposite of bottom. Down is the opposite of up. So in other words, bottom up is more or less the opposite of top down. Bottom up is the opposite of top down, right? Bottom up is the opposite of top down, right? So it means that the advantages of analogous or top down will be the disadvantages of bottom up, and the disadvantages of analogous will be the advantage of bottom up. So let's look at how this works. Let's look at how this works. Okay. So for analogous, we said it's not really a detailed, it doesn't have individual pieces in it. But bottom up, the advantage of bottom up is that we have to create the details first. Bottom up is a more detailed estimate because you know what makes up the 1 hour, 35 minutes because we've broken it down. So bottom up is detailed and estimate, is detailed and accurate. That's the advantage, while the disadvantage of analogous is that it lacks details. That's a major challenge of that. Now let's look at bottom up, the disadvantage of bottom up. So the first disadvantage we're going to talk about is that the time it takes to create bottom up estimates, it takes time. If you compare the two methods I've used, the first method I used Analogous, it was very fast. The second method, I had to list out, break the journey into smaller segments and estimate. So disadvantage of bottom up is that it takes time to create. It takes time to create a bottom up estimate, right? That's the disadvantage. Another disadvantage of bottom up is that team members can pad the estimate to compensate for unknowns. Team members can pad the estimate to compensate for unknowns. So what is that? What this means is that a task that should take 4 days can end up taking, a task that takes 4 days can end up being 6 days because your team members are padded in duration because of risk. And it's a good practice to involve risk when you're estimating because you never know what can happen in a task. So your team members normally add extra days to compensate for risk. Now, but why is it a disadvantage? Imagine that you have 100 tasks in a project and your team members are adding 2 days per task. It simply means that your project is going to have an extra 200 days, right? And 200 days, 10 months. So if we keep adding 2 days to every task for the sake of contingency, it can significantly affect your project schedule with 10 months of extra time awarded to the project, right? But that's not the worst part. There are 2 factors you need to know. One is called Parkinson's law. Parkinson's law. The other one is called student syndrome. Parkinson's law and student syndrome. Now, why is this important? So Parkinson's law states that people will consume the time you give them. People will consume the time you give them. What Parkinson's law is saying is that whether you give this person 6 days or 2 weeks, they'll consume all the time. So Parkinson's law is already saying that risk or no risk, 6 days is what they're going to use because that's what you've given them. Student syndrome will now explain how it will happen. Now, everybody here has been a student once upon a time in your life. You were a student. You're probably still a student if you're doing a master's program or anything like that. So what happens in student syndrome is this. So what happens to students? Imagine a weekend class, Friday, last class for the weekend. The lecturer, in the last 5 minutes of the class, the lecturer is saying that I'm giving you an assignment, submit in 2 weeks. I'm giving you an assignment, submit. Now, if they had sat down for 2 hours, they could have submitted that assignment that day. But what do students do? It's weekend. I need to plan how I'm going to travel. I need to go there. I need to visit someone, and they procrastinate until 2 weeks comes up and the lecturer is asking for his assignment and they are now begging. So that is how students behave, and it also affects how we execute tasks. So this is how, the 4-day task may be executed. So remember, students, they procrastinate a lot. So on the first day, the person handling the task may be dragging their feet. Same thing with second day, same thing with third day, right? So when it's the third day, they know they have 4 days left. And from the third to the 6th day, right, they are now focused on the task. So they more or less wasted day one and day two, and they are now serious. Now, while they are serious on the task, it's possible that a real issue comes up, and a task that is meant to be scheduled for 6 days is now being scheduled for 8 days, right? A task that should be scheduled for 6 days now is scheduled for 8 days, right? So that is how Parkinson's law works. I mean, students procrastinate, and when they procrastinate, they realize that they don't have time left, and then they're now rushing if other mistakes come in. So imagine that a team said it's going to take them 4 days to do the work, but they should give them an extra 2 days for, and they were given 6 days. And they started the work on the first day, second day, they were dragging their feet, got serious day 3 to 6, and eventually the task was delayed by 2 days, right? So you can see that when we talk about right, when we talk about you can see how we went from 4 days to 6 days, now 8 days. The next time this same guys, this same team is working on this task, they'll be asking for 8 days. And when this happens, we call it task inflation. That means the task is getting longer, right, because of inflation, right? So that is the worst part of team members being able to pad to compensate for the estimate. Let's look at parametric estimating. So when we look at parametric estimating, it can be done quickly and is usually accurate. It doesn't really have any known disadvantage. When it comes to Monte Carlo, the advantage of Monte Carlo is the accuracy of the estimates, and because you're using a software, what if analysis can be performed. The disadvantage of Monte Carlo is the time and cost associated with the setup of the tool. Don't forget, Monte Carlo is a software, so it's quite expensive to get, and you still have to configure the software in order to give you the estimate. Please, yes, is this clear? Do we have any questions, please? Do we have any questions? Anybody, please? Any questions? Please, let's take questions if it's not clear. Rhoda, Cynthia, are we clear?
None.
None. Cynthia, any question for me?
No.
Okay, so that means we understand the different estimating methods. So this is time for our break. So we'll take another 10-minute break and come back for the last round. All right. And we're going to look at another estimating method. Now, this is called PERT estimate, and it's an estimating method used when there's uncertainty. So it's used when there's uncertainty in your project. The first time PERT was used was when the US Navy was building their first nuclear submarine. Now, the reason they used it is because nobody had built a nuclear submarine before. So they really didn't know how much time it was going to take. So that's the first time they used PERT. So it's when your estimate, you're not sure of your estimate, that you use PERT. So unlike the other four analogous, bottom up, parametric, you have more information about those kind of estimates. But when you're dealing with PERT, you are not really sure of your estimate. So that's what it's used for. PERT has a very big name, but a very simple formula and approach. It stands for Program Evaluation Review Technique. And let's look at the formula. The PERT formula is P plus 4R plus O divided by 6. And the question is, what are the PERT variables? What are the PERT variables? So when we look at the PERT variables, we are talking about pessimistic, realistic, and optimistic. Realistic is the same thing as most likely. We're talking about most likely estimate. So let's look at an example. Now, I use Lagos-Ibadan trip to explain most of the estimating methods. Let me continue with PERT. So in order to use PERT formula, you need to get the PERT variable. So what are the PERT variables? Number one, we're going to say realistically, what's the most likely duration for a journey between Lagos and Ibadan? And that's 1.5 hours, like I said earlier. Then I'm going to ask optimistically, on the best case, how long will it take us to travel from Lagos to Ibadan? And I say 1 hour, best case scenario. And pessimistically, what's the worst case scenario? What's the worst case scenario? What's the worst case scenario? And I say pessimistically, that's going to be 6 hours, right? And when I say worst case, is that day that you are asking yourself, what am I looking for on this trip? You know, those days that you get one traffic jam and you're like, oh, why is it today? You know, that kind of question. So that's your worst case. So all you have to do now is just put it in the formula. That's PERT. And PERT is given by pessimistic 6, excuse me, 6 plus 4 times R, 4 times 1.5 is 6, plus optimistic, which is 1, all divided by 6. And what do you get? You are going to get 13 over 6, which becomes 2, 1 over 6 hours. And if you're going to cover 2, 1 over 6 hours to hours and minutes, this is going to be 2 hours. Oh, sorry, I put S hours. 2 hours, 10 minutes. So that means the total duration, right, is going to be 2 hours, 10 minutes, PERT estimate. So that's how you use PERT, right? That's how you use PERT in calculating your estimate. Is 2 hours, 10 minutes. You get the pessimistic, optimistic, and realistic estimates, and you calculate your PERT. Okay, so that's it. Okay, now, but there's something more. PERT is sometimes classified under 3-point estimate. PERT is classified under 3-point estimate, right? And what that means is that, and the reason why it's classified under 3-point estimate is because it uses 3 variables: pessimistic, optimistic, and realistic. So that means that PERT is a type of 3-point estimate, and PERT is also known as what? PERT is also known as what? PERT is also known as beta distribution, right? So there are times in exam questions, they may ask you for beta distribution. They are expecting you that you remember it's the same thing as PERT, P plus 4R plus O divided by 6. That's what it means. So that's beta distribution, right? That's beta distribution. Now, another thing is what? So PERT beta distribution is not the only type of 3-point estimate. We have one more, which is called triangular distribution. Triangular distribution. And when we compare it, what's the difference between beta distribution and triangular? So let me try and write it here. So when we are talking about PERT, beta, what's the formula? P plus O plus 4R all divided by 6. That's the formula for beta distribution. For triangular distribution, it is what? P plus O plus R all divided by 3. That's the difference. And so the difference is that triangular distribution is a simple average, while beta distribution is a weighted average. And what do we mean by weighted? It's because one number comes in multiple times. This is like saying P plus O plus R plus R plus R plus R. And it's a weighted average because there are 6 variables. That's why it's divided by 6. So if you are answering a question and they say, oh, please, can you determine the triangular distribution of the estimate when the most likely estimate, most pessimistic estimate is this, and optimistic estimate is that. When they say triangular distribution, you're using. But if they ask you, and they've given you the 3 ranges, to use beta distribution, don't forget that that's the same thing as PERT estimate. Okay, are we good? Are we good with 3-point estimates? So, how many 3-point estimates do we have? Let me ask if we are following. How many 3-point estimates do we have? How many 3-point estimates?
2.
Okay. I think you have 2 devices on Roda, and when they're close to each other, they make noise like that, right? So that's why it's echoing. And PERT is also known as what? PERT is also known as what? PERT is also known as what?
Triangular distribution.
No, PERT is known as beta distribution.
Beta.
Yes, don't forget that. PERT is the same thing as beta distribution. And the difference is in their formulas. One is over 6, one is over 3. One is a weighted average, one is a simple average. Okay?
Okay.
That is that. So don't forget that. Now, there's something we're going to use later, which is standard deviation. The square of standard deviation is called variance, but we're not going to go as far as variance. We're only going to consider standard deviation. And standard deviation comes when we're talking about quality, right? And what is standard deviation? Now, mathematically, this is not the formula of standard deviation. If you've done standard deviation in maths before, you know that this is not the formula. But this is the one we find in the PMBOK guide. So you can just say this is the one you need to know. And it's the same P minus O divided by 6. So when we get to quality, there's something called sigma. And we have 1 sigma, 2 sigma, 3 sigma, and 6 sigma. So that's where we're going to talk about standard deviation. So in the example I gave now, I said the worst case scenario is 6 hours. The best case scenario is optimistic is 1 hour. So how do we calculate that? That'll be P minus O divided by 6. It means that my standard deviation, SD, is going to be 5 over 6 hours because it's going to be 6 minus 1, right, divided by 6, which is going to be 5 over 6 hours. So that's the standard deviation. And I can use this to determine, right, how the likelihood of getting to Ibadan at a particular time, right? Especially if my average is 1.5 hours. So there's a way you can use standard deviation to calculate the accuracy of your journey, but it's beyond the scope of this course. So I don't want to go beyond that. But standard deviation is going to be used later on. Just note that, just have that at the back of your mind. So let's move on and talk about the next process. Now, the reason why we talked about estimated activity duration And the reason why we started talking about estimating methods is because we're going to use them. So in estimating the duration of activities, we're going to use analogous estimating. So if you've done the activity before, you can just use analogous or parametric estimating. If you have parameters, so let me give an example of parametric estimating. A tiler can lay 2 square meters of tiles in 5 square meters of tiles in 2 hours. How long will it take him to lay 100 square meters? If it takes him 2 hours to lay 5 square meters, and he has 100 square meters, then it's going to take him 40 hours, right? How did I get that? I had a parameter. He lays 5 square meters in 2 hours, right? So we can use parametric estimating, right, to get the estimate if we have parameters. And don't forget our 3 points, but you have 2 3-point estimates. So when you want to do 3-point estimate, it's possible that you can use what do you call it? You can use parametric, you can use uh, beta distribution or PERT, or you can use triangular distribution to calculate your estimate. Then you can also do bottom-up estimating, and you can look at alternatives. So you can come up with different alternative estimates, right, based on different techniques. And then you can also factor risk into your estimate. So if there's a risk that you've identified, that's why the risk register is an input. If there's a risk you've identified and you want to ensure that if the risk happens, you can add it, you've added enough time to take care of the risk, you add it as a reserve. So let's say your task is meant to take 4 days, but because it's you're doing the task within a risky period, then you can add 2 extra days. For example, one of the risky periods of construction is the raining season. When it starts raining, the ground is slippery. So a task that would normally take 4 days, because of that risk, you may decide it will take 6 days or 7 days in the heart of the rainy season. So that's what we mean by reserve analysis. Then you can make decision making. This is in the PMBOK guide. We call this the fist of 5 voting. Fist of 5 voting. Fist of 5 voting. What does this mean? So when we talk about fist of 5 voting, this is where you make estimates by using your hands. So, and it's a team, it's your team that gets involved with this voting technique. Now, I don't know if you know, when let's say you're using a scale to vote. So when you say, I agree, strongly agree, right? Agree, right? Strongly disagree, disagree, and so on. That's how fist of 5 voting is. So let's say I call out an estimate, right? And let's say I'm saying that this task should take 3 days. Now, the team members are the ones doing the task. If they all agree, they can bring out their 5 fingers. If all of them bring 5 fingers, they are saying that they agree totally that it will take 3 days, right? If they bring 4 fingers up, it's like strongly agree. If they bring 3 fingers up, it means they agree. So the intensity for agreeing starts with 3, it becomes more with 4, it becomes more with 5, and 5 is the maximum. Now, if they don't agree with the estimate, they will show 2 fingers up. 2 fingers means they disagree. If they show 1 finger up, it means that they strongly disagree. If they show a fist, like a fist, you want to punch someone, then that is strongly disagreeing. Fist of five voting is normally used in Agile, not a waterfall tool. It's more or less an Agile tool, and that's where it comes in, right? And then when it comes to estimate duration, you also want to have meetings with your team and other stakeholders to determine the duration estimate of your project. Now, I did talk much about the input, but if you're going to consider input in estimating the duration of your task, the input will involve the activities that you want to estimate and the resources that will be assigned to the activities. Resources are important when you're estimating tasks because the quantity of resources you assign to a task will influence the duration. If five people can clear a piece of land in 4 days, how many days will it take 10 people? So the quantity and type of resources that you assign to the project will influence a great deal the time. And that's why you can do alternative analysis, because if I have different types of resources available to me, I can come up with different duration estimates, which means, let's say you want to clear a piece of land and you're thinking of using 7 laborers, right? That's one alternative. 7 laborers may spend 2 weeks. But what if I use a tractor and clear the land in a day? That's another alternative. But that alternative will also influence cost, other things. So when you're doing alternative duration estimate, you should also factor other areas of the project, like cost. So at the end of the day, you have your duration estimate for the task, depending on the techniques you've used. Now, it's not a must to use all the techniques, but you must be able to ensure that you agree with the estimates you are getting from one or two or several techniques. You understand what I'm saying? So for each task will have its own duration estimate. Each task in your project will have its duration estimate, and every duration estimate must have a basis of estimate. So what do we mean by basis of estimate? Basis of estimate are the assumptions you made to generate the estimate, the constraints. Let me put assumptions and constraints factored into the estimate, the method or technique you use to create the estimate, the range of possible estimates is also uh, a possible estimate, range of possible estimate, and the confidence level. So now, when we, so whenever an estimate is made, a supporting document is basis of estimate. So remember tiles, right? We have 100 square meters, 100 square meters of tile floor to be laid. And our estimate is, our estimate is 40 hours. How did I get there? That when you check the basis of estimate of that duration estimate, you should see the assumptions and method. Method, we use parametric, right? We used the parameter of the tiler laying 5 square meters of tiles in 2 hours. That's a method we use, and the so that's the method that was used and the parameters that were used. So if all your estimates have an explanation of the method and assumptions, range of possible estimate, that is what we call basis of estimate, which means whatever duration estimate you create, there must be a basis of estimate that explains to anyone how you came about the estimate that you have just created. Okay? All right, that is it. So now this is the moment we've been waiting for, and I'll explain why I'm saying that. Since we started this knowledge area, there was a diagram that we saw at the beginning, which I'm going to reference back. So when we look at the schedule processes, right, we've talked about virtually all the processes from creating your schedule management plan to defining and listing activities under the work breakdown structure to sequencing activities, which we talked about today, using creating a network diagram, and what we just finished talking about, estimating activity duration. You find out that everything that we did was actually done so that we can create a schedule. So this is where we are. And this is why all the arrows are coming in here, because the ultimate goal of what we are doing in this knowledge area is to create a schedule. And in order to create the schedule, we need a network diagram, we need the duration estimates of each activity, and we need the list of activities that need to be scheduled, including resources. So everything we're doing was actually a build-up to actually get to the point where we are ready to create this schedule. And everything that we've done so far was done for the purpose of developing a schedule. Everything, including estimating duration of activity. So you notice that, right, in order to develop the schedule, right, what are we doing? In order to develop the schedule, right, we have, first of all, the activity sequencing, right? Activity duration estimates, the resources assigned to the task, resource requirements, right? And these are some of the things that we've talked about. We have to look at the activity list and work breakdown structure. That's the what, the when, the start and completion dates, the who, the resources that we assign, and the sequence, the order in which the activities go. All these things have been discussed earlier as part of the processes to develop your schedule. So if you look at the inputs and you look very carefully, you find out that a lot of outputs that we've talked about has already been factored as inputs. So first of all, the schedule management plan will govern the method and approach and tools that we're using to develop the schedule. So, and this was the first plan that was created in this knowledge area. Another thing is the list of activities and their attributes was the output of defined activities. So now we know the list of activities that need to be scheduled. We also know their duration estimate. That's why where we're talking about PERT and our logos and so on. So we have estimated all the duration activities. We also have the network diagram, the sequence of all the activities. Then lastly, we also have the resources, people, material, and so on that will be assigned to the activities. We can also factor in risk, right? Because risk can affect your schedule. So if there are any contingencies or things that we should factor into the schedule, we will find it in the risk register. And then agreement. This is very important because when you're building a schedule, if contractors are going to be working on different areas of the schedule, then their agreement towards the schedule must be factored in. So if a contractor has an issue and that issue is going to affect their schedule, that should be documented in the agreement because you need to ensure that your contractors can also align with your schedule. So you have to factor that in when you're scheduling the project. So these are the inputs, right? In developing your schedule is actually the inputs are part of the work we've done, including resources that we assign to project activity. So let's go into tools and techniques now. Now, you find out that anytime I'm taking this course, I spend more time in tools and techniques than input and output. And the reason is very simple. The tools and techniques are the things that actually convert input to output. So if you don't understand tools and techniques, you're not likely to carry out the process. So let's look at each of them. So the first one we're going to talk about is schedule network analysis. Schedule network analysis. Now, schedule network analysis talks about analyzing the network diagram. And there are two things that we can do here to analyze the network diagram. One is critical path method, and the other one is called resource optimization. Critical path method and resource optimization. So when we talk about critical path method under schedule network analysis, right? When we talk about critical path method, um, critical path method involves you analyzing the network diagram. So it's a subset, which means anytime you're doing critical path method, you're also analyzing network diagram. Anytime you're doing resource optimization, you're also analyzing network diagram. So critical path method and resource optimization are scheduled network analysis techniques. I would explain what all of them mean and how you analyze a network diagram, get it done. Then we have what we call what if scenario analysis and simulation. Now, why do we need this under data analysis? We need this so that we can stimulate, right, and come up with scenarios that can help us determine how long the project will take. So we can come up with multiple scenarios to tell us, oh, this project will take 6 months based on the scenarios. Based on our simulation, this project is likely going to take 1 year. So you can also use that to determine the duration of the project. Then leads and lags. About leads and lags. Leads, any opportunity to overlap tasks to save time, and lags can be put when we have delays between tasks. We also have schedule compression techniques. What do you mean by schedule compression techniques? These are techniques that help us to, what do you call it, save time in our project. There are two major schedule compression techniques. We have what we call crashing, and we have what we call fast tracking. Don't worry about, we're talking about so many things at the same time. We're going to look at them one after the other, crashing and fast tracking. And then we also have what we call the project management information systems. This is simply talking about using a scheduling software, right? Remember what I said about, so for example, to schedule your project, you can use, if it's waterfall, you can use MS Project, Primavera, right? If your project is agile, then you are using tools like Jira, Asana, ClickUp, right? So scheduling software is what web project management information systems come to. Now, if it's an agile project, then we're talking about using agile release planning, right? So at the end of the day, after implementing the necessary tools and techniques, we are going to build a project schedule, and that project schedule can be baselined as to serve as a reference. I will show you quickly what this means. Then, when you build the schedule, you can now get data from the schedule. For example, when should task C start? You can see it on the schedule. What are the resources assigned to task C? You can obtain schedule data. Then project calendars. You can now decide which calendar to operate in. So when we talk about project calendars, what do we mean? So we have default calendar, which we can call day calendar. So the normal daily working calendar is anything from 8 a.m. to 5 p.m. That's our normal working hours. That's the day calendar, right? Which is the default calendar. But let's say that your project is only scheduled for night. The night calendar starts from 8 p.m. to 5 a.m. Now, and there was a particular project in Lagos that actually operated this way. Now, what happened was that the bank wanted to renovate the bank needed to renovate its what do you call it? Yeah, the bank needed to renovate its banking hall, and they didn't want to disrupt the what do you call it? The normal banking hours. So they decided to work night, right? And that's where they got the 8 p.m. to 5 p.m. All right. So please give me a minute. Please give me a minute. The, so we have the daytime calendar, that's 8 a.m. to 5 p.m. We have the nighttime calendar, that's 8 p.m. to 5 a.m. We also have 24/7. So there are some projects like in the oil and gas and construction that they have a 24/7 calendar. That means you have people working either 12-hour shifts or 8 hour shifts. If it's 8 hours shift, then it means that 3 shifts are working continuously on the project. Now, this is how construction is done in places like China and Dubai. Continuous execution of the project, right? And that's what we're saying. So, so that's another type of calendar, right? 24/7, day, night. I think that's about. And then you can have custom calendars. You can create different types of calendars, and that's that. So those are the major outputs here. When you develop a schedule, these are things that you most likely create. Now, I'm going to show you, I think I have enough time to show you the difference between the project schedule and schedule baseline. The difference between project schedule and schedule baseline. So let me show you using Microsoft Project. So just give me a minute and let me pull out my project, MS Project, right? MS Project. Just a minute. MS Project. Okay, so the project schedule and schedule baseline are things that you need to know. And so I will share it. Okay, so let's look at it. So this is it. Excuse me. All right, let's look at this. Let's look at this. So once you've scheduled a project, if you're using a software like Microsoft Project, it should look something like this, right? And what this means is you can see the task, you can see the duration of the task here and so on, right? In fact, so this is and of course, if the project is waterfall, it's not agile. This is one of the most popular tools to use. So I want to explain something here. So let's say that we have completed the schedule of this project. and it says here 147 days. If the sponsor client is happy with it, what happens is that we're now going to baseline it. So baselining a project is something you do deliberately, and I'll just set a baseline. So you can see I'm clicking on set baseline, and I want to set baseline on the entire project, and I press OK. Now, once I've done that action, the project has been baseline. Now, but you need to do something in order to be able to see the baseline. In order to see the baseline that we've just selected, I'm going to click on baseline and select this one, baseline last saved. And when I click it, just look at, do you notice every task is blue? But when I click on baseline, I'm asking Microsoft Project to show me the baseline I've set. And what do you see? Do you see any difference when I clicked on the baseline? I just want to be sure that we're following. Do you see any difference, please? Do you see any difference? Cynthia, Rhoda? Yes, the color changed, but it didn't change completely. So what happened is that if you look at this dark color is the baseline. This blue color is the project schedule. So we have the project scheduled here, and then you have the baseline underneath. We have the project scheduled here, and we have the baseline underneath, right? So, and these two are outputs of developing your schedule, which means when you develop your schedule, you should have both the project schedule and the project schedule baseline. Now, the question is, why do we need to baseline the schedule? The reason is because, this is a plan, and it's not every time things go according to your plan. So the baseline becomes a reference. So let me give an example where it will be needed. So this is a plan. This could be even starting next month, not today. So just imagine that when the project starts, reinforcement works that I plan to take 14 days eventually took 16 days. Let me make it. Now, look at what happens when I press enter. It's originally 14, but when I press enter, it will update it. I'm pressing enter now. Just look. Do you see what is going on? Do you see what is going on? I don't know if you see the shift, right? Did you notice the shift? Hello? Hello, can you guys hear me?
We're here.
Yeah, did you see the shift?
No, I didn't see the shift now.
Okay.
When the network froze.
Oh, it froze. Okay. Did you see the shift, right? Okay, let me go back to 14 days. It was originally 14 days. Press enter. Do you see how it is now? Now, in real life, what I planned to be 14 days took 16 days. Can you see this now? Can you see how we jumped forward?
Yes.
Can I get a feedback? So what is going on is that the project schedule has gone ahead by 2 days, but the schedule baseline is still where it was. Now, the reason we have the schedule baseline is so that we can track variation. How far we've gone away from the actual plan. So you can see it's going down all the way, right? That's why we have the schedule baseline, so that when the project is changing, we can still see the reference point where we really ought to be in each task. So as a project manager, I've lost 2 days here because I've lost 2 days in this task. I have to figure out where I can save 2 days. And my mind is telling me that if I if I can save 2 days on this task, what's the name of this task? Reinforcement workforce slabs. It's 5 days. If I can add more resources here, maybe I can save 2 days. So what I'm going to try and do is add more resources, and adding more resources will mean that they do it faster. And I look at what will happen if I can save 2 days on reinforcement workforce lab. Look at it. Do you see what happened? I've gotten the remaining tasks afterwards are back on the baseline. Please confirm you saw that. Did you guys see that?
Yes. Yes.
Yes. Now, do you see the importance of schedule baseline? Without the schedule baseline, I'll just be managing my project blindly. I'll just be making changes, and I don't know where the reference is coming from. And that is why a schedule baseline is important, because you can set it. Once you set it, all your project will be moving forward and back. You will know what needs to be corrected. Without the schedule baseline, we are just we're just managing our schedule blindly. This is why, and that's why anytime I'm teaching this aspect of the the course, when it talks about schedule baseline and project schedule, it's better you see it so you understand it. That when you create your schedule, you create the project schedule, then you baseline it so that when you start making adjustments, you can keep track of where your project ought to be. That's where the schedule baseline is. And in some instances, the schedule baseline can be updated if there's a need for that. So this is all the time we have for today. And yes, I have 1 minute left. And tomorrow, we're going to be talking about the tools and techniques like the critical path method. We're going to talk about critical path method. We're going to talk about resource optimization. We're going to talk about schedule compression. And we're going to talk about these three tomorrow in detail. So please let's not miss tomorrow's class. And we've covered what we did last week and did more today, so which is okay, right? So please don't miss tomorrow's class. All right, let me wish you a lovely day ahead, and let me say